Welcome back, everyone! Today we're going to wrap up our discussion on Mycobacterium tuberculosis and talk about how a pathogen creates cell damage in its host. But first, let's talk about how Mycobacterium tuberculosis is spread. TB bacteria are spread through the air from one person to another, carried in airborne particles called droplet nuclei. The TB bacteria are put into the air when a person with TB disease of the lungs or throat coughs, speaks,
Hi, how are ya?
or sings. People nearby may breathe in these bacteria and become infected. This means that you can't get sick from other things like clothes, drinking glasses, utensils, or other surfaces like a toilet. So make sure if you have it, you wear a mask. After a host is infected with MTB, there's a 10% probability that he or she will develop active tuberculosis and the bacterium may invade multiple organs. Healthy individuals can be infected via the respiratory tract, the digestive tract, damaged skin and mucous membranes, and inhalation of droplets containing MTB is the main route of infection. The bacterium then resides in the lungs for a long time and remains dormant until it emerges for an effective purpose. Once TB becomes infectious, it targets killer immune system cells called macrophages and resides in them so that no other killer cell can recognize them. The tuberculosis bacterium lives in macrophages that are the guards, waste removers, and caretakers of the immune system. The main role of macrophages in the immune system is to eat and destroy microbes while alerting the rest of the immune system. TB bacteria have found ways to hide inside the macrophage and avoid being killed. While macrophages would usually attack the bacteria, TB is able to live within it without dying and with the help of several chemical mediators and degrading enzymes. The cell wall structure of TB is extremely unique among prokaryotes because its cell wall is composed of lipids and peptidoglycan, mycolic acids, cord factor, and wax-D coated with an unusually tough outer shell, kind of like a molecular bomb shelter that can protect it against the threat of immune system and drugs. This unique shell makes it impermeable to stains and dyes, acidic and alkaline compounds, resistance to osmotic lysis via complement deposition, and resistance to lethal oxidation and survival inside the macrophages. The MTB can invade the immune system because it is able to grow, divide, and thrive intracellularly in the macrophages. It can block the inhibition of phagosome-lysosome fusion and phagosomal acidification by blocking the proton transporter. It can also block the maturation of phagosomes. Internalization of the bacteria triggers an inflammatory response by the macrophages, which brings other defensive cells to the area. When all together, the cells form a mass of tissues called a granuloma. In the early stages, the granuloma has a core of infected macrostages surrounded by other cells in the immune system. As cellular immunity develops, macrophages loaded with bacteria are killed, resulting in a caseous center. The strength of the body's immune response determines whether an infection is arrested here or progresses to the next stage. Misobacterium tuberculosis does this by punching holes in the membrane that encloses the macrophages. This triggers an explosive immune response in which the cells that they live in die, allowing the bacteria to spread to other cells. The bacteria operate in two modes, one where they divide and multiply while hidden inside the cell they live in, and one where they break out and infect healthy tissue. The tuberculosis bacterium uses a specialized secretion system to release its array of toxic proteins into macrophages. But strangely, it also releases small bits of DNA which are detected by sensing systems inside the macrophages. This causes macrophages to release two types of proteins, interleukin-1, which fights the bacterium, and type 1 interferons, which end up helping it. If the immune system is compromised by immunosuppressive drugs, HIV infections, malnutrition, aging, and other factors, The bacteria will continue to replicate and escape from the granuloma and spread to other parts of the lung. In some cases, the bacteria might also spread to other parts of the body through the lymphatic system or the bloodstream. When the tuberculosis bacterium makes a person sick, it's because cells full of bacteria rupture and spread their contents to other cells in the lung, creating inflammation that damages lung tissue. The person begins to cough, and then the bacterium spreads. All of this sounds really scary, right? So how can you prevent the spread of TB? First off, if you think you have TB, make sure you go to your doctor and get treated right away. Always cover your mouth with a tissue when you cough or sneeze. And wash your hands often, especially after you cough or sneeze. Thanks so much for tuning in. We hope to see you again real soon.